Question 7. So we first have to go through what should be an algorithmic process. Just simply do what you've always done. If you practice these carefully, it should be easy to just simply work out what r and theta are. Sorry, what r and alpha. Let's go ahead and do that. Zoom out a little bit. So we first need to explore r cos theta minus alpha. Now, if you look in the formula book for the compound angle formula for cos, we find, let's write it somewhere maybe out the way. Let's put it here. Cos, sorry, I'll use a less lurid colour. Let's use red. So we find in the formula book that cos A minus B is equal to cos A cos B plus sine A sine B. And therefore, the expression we've been given, r cos theta minus alpha, can be written r cos theta cos alpha plus r sine theta sine alpha. Now compare that to the 3 cos theta plus 4 sine theta we've been given. If we write that underneath, we've been given 4 cos theta plus, sorry, no we haven't. We've been given 3 cos theta plus 4 sine theta. Okay, now compare these. These have to match up. So we've got our cos theta. So the bits that I haven't highlighted there must be the 3. So r cos alpha must be 3. And similarly over on the second expression, we've got sine alpha catered for. So r sine alpha must be 4. Now, the r, it's worth just knowing that r you can find by effectively doing Pythagoras on the 3 and the 4. So I'm just going to do that over here. R is going to be the square root of 3 squared plus 4 squared. That always works, just do it, and you get out your 5 straight away. To work out alpha, you can substitute that value into one of these 2 equations here and work out what alpha is. That works fine. But perhaps a more efficient method, if I just number these, if I'm going to call that equation 1, equation 2, if we do equation 1 divided by equation 2, then we've got our sine alpha divided by our cos alpha, which is just tan alpha. The r's cancel and sine over cos is tan. Equals, make sure you get it the right way round, 4 over 3. A lot of people in the test wrote 3 over 4 there and got the wrong answer, which was a bit annoying. Just take care over these things. It's this one divided by this one. Great, that gives us alpha is 53.1. 1 decimal place is sufficient for angles in all cases. Okay. So we've got, just to finish part A, we should actually do what it says. It says express it in the form. It doesn't just say work out r and alpha, it says express it in the form. So therefore, or this implies that we have 5 cos theta minus 53.1 degrees. Now, I'm going to come over to the left-hand side. Hopefully we'll have enough space. If not, I'll just erase some stuff. But this is central to understanding how to go any further with this problem. So hence find the maximum value of that thing there and the smallest value of theta for which it occurs. Again, in the test, a lot of people didn't notice that it's the same expression in parts A and B. And the fact that we put it in this form here is critical. You have to use it in that form. So what we're really finding is the max value of 5 cos theta minus 53.1 degrees. Now, if you plotted a graph of that, it's just going to go between 5 and minus 5, because it's 5 lots of cos theta. Now, the cos part of this simply oscillates between minus 1 and 1, and therefore 5 times that is going to oscillate between minus 5 and 5. So max value is 5. Simple as that. Smallest positive value theta for which this maximum occurs is asking basically, well, when is 5 cos theta minus 53.1 equal to 5? When does it assume that maximum value? And of course, that's when cos theta minus 53.1 is equal to 1. And if we inverse cos both sides, we get theta is 0. Theta minus 53.1 is 0. We don't need to go off and look for other solutions. The principal value is fine. Theta, therefore, is simply 53.1. Same value that we got in part A. So that's that. Brilliant. So let's consider now part C. Before I do that, I'm just going to clear a bit of space over on the right-hand side here. I'm not going to erase this because we're going to need it again. So let's bring that up here, out the way. So part C. So reading the text before it, the temperature is Ft of a warehouse is modelled by this equation. Again, you're not going to be able to solve this unless you spot that once again we're dealing with the same expression. Now I haven't even read the question yet, but I know from experience I know I don't even need to yet. F of t simply needs to be written 10 plus, and then this bit here, but in the new format. So 5 cos, now theta is now 15t, so 15t minus 53.1. Okay, now let's actually read the question. Calculate the minimum temperature of the warehouse as given by this model. Well, this is nice. It's just 5 degrees, but for not the same reasons that this was 5. Again, we just need to look at how this expression, this function, changes as t changes. Well, we don't need to worry about the ins and outs of it. All we need to spot is that this part of it, the cos of something goes between minus 1 and 1. It can only operate in that range. It goes from minus 1 to 1. So at its absolute maximum value, when it's 1, the temperature would be 10 plus 5 lots of 1, i.e. 15. But the question asks us for the minimum value, so it's going to be 10 plus 5 lots of minus 1, which is of course 5.